this video we're going to continue looking at tree diagrams. We're going to take the idea a little bit further by looking at something called non-replacement, and I'll show you what that means in a second. To start off with, let's have a look at this question. There are 5 sweets in a bag, 3 blue and 2 green. George takes out a sweet and eats it. He then takes a second one out and he eats that one as well. So this one is slightly different in the sense that when I do my first pick, George has the option of a blue or a green sweet. The probability he gets a blue sweet is 3 over 5, and the probability he gets a green sweet is 2 out of 5. Now in previous examples this would just repeat on my second pick, but actually what's happened here is that one of my blue sweets has now disappeared. So if one of them's now gone, there are now only 2 blue sweets out of 4 in the bag in total. In terms of the green sweets, there are still 2 in there, but there are now only 4 sweets in total in the bag. If I just rewind and go back to the start of my tree diagram, let's say George actually took out a green sweet to begin with. That means that when he comes to his second pick, he can still get blue or green, and this time there are still 3 blue sweets in the bag, but there are now only 4 sweets in total. There is now only 1 green sweet and 4 sweets in total. So this is my tree diagram completed. What I need to do is think about the probability of getting 2 green sweets. So this only happens in one place on my tree diagram. It's down here, GG. So I'm interested in the probability of a green and another green. So if you remember from tree diagrams number 1, we're going to multiply these together to get 2 over 20, and I may want to simplify that down to 1 over 10. The probability of getting different coloured sweets, well, that's going to be here with blue-green, and it's going to be here with green-blue. So the probabilities of these happening is 3 times 2, which is 6, and 5 times 4, which is 20. And then if I follow these branches, it's 3 times 2 again, which is 6, and 4 times 5, which is 20. Now, I'm interested in what happens if I get blue-green or green-blue. And from the previous video, you should remember here that I need to add these together to get 12 out of 20. And this thing will simplify down nicely to 3/5. And that's that part of the question completed. Pause the video here to have a go at one of these yourself. Take care. I've deliberately not drawn the bag in this one for you, so you're going to have to think very carefully about what this bag looks like before the first pick and after the first pick as well. Pause the video here. When you're ready for some answers, hit play and I'll talk you through it. Okay, let's have a look at this one then. So first of all, 2 things can happen when I do my first pick. I can get a gold coin or a silver coin, and that's my first pick there. Now the probability of getting a gold coin to start off with is 5 out of 8, because there are 8 in the bag in total, and the probability of silver is what's left, so 3 out of 8. On to my second pick. Now on the second pick I can still get another gold, I can still get silver, and this time the probabilities have changed. There is 1 less coin in the bag, so it's out of 7, and there's also 1 less gold in the bag, so it's now 4. The number of silvers hasn't changed. There are still 3 silvers in the bag, and there are 7 coins in the bag. If we just rewind back to the start of my tree diagram, if I'd have taken a silver first, I could still have taken gold or silver, and this time the number of golds is unaffected, so there are still 5 there, but there are 7 coins in the bag. Along this branch I've taken 1 silver out already, so there are now only 2 left and 7 in the bag in total. That's that part of the question complete. The probability of getting 2 gold coins is here, gold, gold, and that's 5 times 4, which is 20, and 7 times 8, which is 56. Now I'm not going to simplify down just yet because I want to have a look at the rest of this question. Part 3, what is the probability of the same colour coin? Well, here I'm interested in what happens if I get gold, gold or silver, silver. So let's work out the probability of silver, silver. I'm going to do 3 times 2, which is 6, and 7 times 8, which is 56. Now these two, remember I said I want this one or this one. So to get an OR rule, we add them together, giving me 26 over 56, which I'd simplify down to 13 over 28. If I just go back to the second question before I finish up, the probability of getting 2 gold coins was 20 out of 56. Now I can simplify this thing down to 10 over 28, 5 over 14, and I'm happy that that's in simplest form. The reason why I didn't simplify initially was because it's much easier to add these fractions together when they've got a common denominator. Well done if you got that question correct. That's an A* tree diagrams question.